Hey, I'll share the notes for 7.1, solving by graphing. So let's talk about this idea for a minute. Anna chooses between two phone plans. The first plan costs $20 per month, but the calls cost additional 25 cents per minute. The second company, Cellnet, charges $40 per month, but the calls only cost 8 cents per minute. Well, which one should she choose? Well, it kind of depends. Is she going to be using her plan mostly for calling, or is she going to just use it for other things? It kind of depends. If we want to actually solve this problem, we have to start by setting up the problem. So if we're just going to talk about this first one, let's call this V. If we're going to write about plan V, we know that each month they're going to charge a set rate of $20. But each additional call is going to be 25 cents per minute. If we're going to start in dollars, we should put this one in minutes, so we have to do 0.25. But if we don't know how many minutes she's calling, that has to be represented with X. So X is however many minutes she ends up calling that month. Now, the second company, we'll call it S. Their price can be modeled very similar. They start off with $40 as their set rate, but each additional call costs 8 cents per minute. 0.08. Again, we don't know how many minutes she's going to be calling, so we're just going to write it as X. Now, if we're going to look at the graph of this, let's just set that up. Let's do a really rough sketch here and say that this first company, we're going to start it at $20, and it's going to go up a rate of 1/4. So I'm just going to do a quick sketch. I know that that would go up at roughly this rate, let's say for now. With 8, this is going to be 8 cents a minute. So this line represents the function 20 plus 0.25x. Now, our other company starts up higher at $40, but they do not have as steep of a slope. They only go up by 0.8. That's going to be significantly less steep. Still going up, but not quite as fast. And at some point, they're going to have to meet. So this is the function 40 plus 0.08x. So what does this tell us? Well, if we look at this graph, it says that up until this point, the $20 plan is going to be cheaper. It's going to cost us less money because that's what's on this axis. If we're talking about it down here, this is going to be minutes. So up until this point, this plan is going to be cheaper. However, after we cross this point, suddenly the $20 plan is more expensive. So after a certain number of minutes, we would want to switch to this phone plan. Well, what point is that? If I know that I talk 100 minutes per month, I could figure out which one of these plans I should go with. And that's what we're going to be solving, is saying which one's a better idea. So one method of solving these systems and figuring out what that happy point is to graph them and see where they intersect. So let's actually do that down here. I need to turn my camera just a little bit. There we go. So let's say we have two pieces here. Well, we're going to graph these. I've told many of you that a y equals line, because it has no slope, it's going to go through at -2 and have a slope of 0/1 or up 0/1, 1 over 1, yada, yada, yada. And it's going to look like this. That's my y equals 2 line. My line can't quite graph. I can either use the intercept method or I can use the the slope-intercept form. That's the one that most of you are comfortable with, and so it's going to be the one that I'm going to show you here. If we want to use the intercept form, we have to bring this over, and we have to solve it for y. How do we solve this for y? Well, we have to get everything away from y. The first thing we should worry about is moving this term away. Once we've done that, we've got y pretty close to being by itself. Now that 3x isn't attached, but there's still a pesky -1 out in front. So we're going to divide everything by -1, both of these terms. When I do that, I get y equals -3 over -1 is just +3. -1 over -1 is just +1. And then we graph it. We say we start at +1 because that number is not attached to the x. And then our slope is 3, so we're going to go up 3 over 1. Now it's a little hard to tell because it's off the graph, so I'm also going to go down 3 and back 1. It's just the opposite of that slope. And then I'm going to use my straight edge, of course, to draw those. Now if I've drawn my lines properly, and this is so important in this unit, because if you don't draw them, you're not going to be able to get the correct point. Well, where did these two lines cross? It's at this point right here. What is that point? -1, -2. So at -1, -2, these two equations cross. Coincidentally, this is also where these two equations are equal. So if I were to plug in -1 and -2 into my original two equations, you would see that they both are equal. Let's try another one. Let's go over here to number 2. If we're going to do number 2, the first one's pretty simple. We've got 1/2 x. Notice there's no term out behind this one. There's nothing to tell us our intercept. So I add a +0 just to remind myself that I'm going through at the origin. Then I recognize that the number connected to x is going to be my slope of up 1 over 2. A slope of 1/2 means up 1 over 2, just as a quick reminder. Alright, I put my extra dots in there and draw my line. Okay, there's the first one. Second one, not in a y equals form, not in my y equals mx plus b. So I'm going to bring that over, and I'm going to move, I should actually do it this way, I should say x plus y. If I want y by itself, I want it to be in the form y equals mx plus b. I need to move this x away. I need to say I'm going to subtract it from this side, I'm going to subtract it to that side. I get y equals -x plus 3. Notice again, this is my y equals mx plus b. If you want to put the x out back, you can. I just really don't prefer it. I would rather have it out here. Because then I can see that my 3 is my y-intercept, and my slope is -1. So I'm going to go down 1 because it's a negative, over 1. Down 1 over 1. If I keep doing that, I'm going to connect my dots here. And I see that they cross at the point 2, 1. So my solution is this point. Now, if we read our directions, it also says that as we're going along, we should decide if each one has one solution, no solution, or infinite solutions. Well, when we look at these first two, what do we get as our result? We get one specific point. So if we get one specific point, we get one specific solution. What does it look like, however, when we solutions, or infinitely many? Let's take a look at this next one. I'm going to solve this first one for y by moving the 2x to the other side. So I have -2x plus 6. I'm going to solve this one for y by moving the 2x to the other side. So I get -2x minus 2. Now that I've got those, I'm going to graph them. Let's graph this first. So +6, I go up 3, so there's 6. I have a slope of -2, so I go down 2 over 1, down 2 over 1. I graph. Okay, there's my first line. And then I'll graph my second line. I start at -2, and then I have a slope of -2 over 1. This is the same thing as, I've said this before, but let's just remind ourselves. -2 over +1 is the same thing as +2 over -1. So if I can't go down 2 and over +1, I can also go up 2 and back 1. so that I have my points on my graph. Whichever one you prefer is fine. All right, there's my second line. What's the first thing you notice about these two lines? You should notice that they are what? They have the same slope, which means they are parallel. Now look at this a minute and tell me, if those are two parallel lines, they will never meet. So where they have a cross like this, where it would give me one solution? It's a trick question. They will never meet. So there's no point that we could definitively say, yes, here's where the graph equal. Since there's no point, we say that these graphs have no solution, because there's no point in here that matches. All right, let's jump to our last one. One of these is already solved for y, but let's move this one over and solve it as well. Notice this is being multiplied by 2, so I'm going to need to divide everything by 2. So I get y equals negative 2x plus 2. And then, of course, I get my other one, which is y equals negative 2x plus 2. Oh, what do we notice here? They are the same line. So let's graph one of them at least on here so we can see what we're working with. I start at positive 2, go up 2 on my y, and then my slope is down 2 over 1, down 2 over 1, yada yada. Put my straight edge on here. Now if I graph this twice, it wouldn't do much because they'd be the same line. Now if I'm questioning what my solution is, I have to find a point that these two lines have in common. Well, what point do they have in common? Oddly enough, every single point on this line is going to be a solution. So if we have two lines that go on forever and ever and ever on to infinity, how many points on that line are going to be a solution? All of them. So when we have two lines that are the exact same, since we can't identify one point, we are going to say that we have infinitely many solutions, or infinite. Either one, the shorthand is fine too. But this has infinitely many solutions. So let's do a quick over 7 points. My graphs intersect never. If they never ever intersect, if they're parallel, they will have how many solutions? 0. No solutions. What about if my graphs intersect once, like these two up here? Then they're going to have one solution. But what if they are the same line? They should have infinitely many solutions. That's all there is for 7.1 to solve by graphing. The biggest thing here is if you're looking for tips and how-tos, I always like to write a little reminder to say, how do I do this? So if I'm doing my steps, I'm going to graph both lines. You can use the intercept method that we learned in 4.5, or you can use the slope-intercept method that we learned earlier. Either one's fine. We're going to graph both lines. We're going to see where or if, because they won't always, where or if they intersect. And then you're going to write the point at which they intersect if it exists. There you have it. There's your overview for 7.1. Let me know if you have any questions.